Hey guys, today we're going to solve the longest palindromic substring problem. We're given a string S, and we have to return the longest palindromic substring in S. The example here is BABAD. How do we do that? Well, there's two parts here. We need to find both a substring and a palindrome. We know a substring is just a sequence of characters within this string that are contiguous. And we know that a palindrome is just a sequence of characters that is the same when read forwards as it is read backwards. All right. Well, without thinking too hard, we can just do a brute force solution, check every single substring, and then check each substring to see if it's a palindrome. Let's start with all substrings rooted at B and ask ourselves, is B a palindrome? Yes, it is. So it now becomes our longest palindrome. Is BA a palindrome? No. Is BAB a palindrome? Yes. So now that becomes our longest palindromic substring because it is longer than B. We'll keep checking BABA, and we'll go all the way to D. So now we've checked all substrings rooted at our first element B, and we'll check all substrings rooted at our zeroth element B, and now our first element A. All right, so we check A, we check AB, we check ABA, and so on and so forth. Until eventually we have whatever answer, which turns out it is actually going to be BAB. What's the time complexity of that? Well, to check every substring, we're going to have to go through every character and then every other character. So that's n squared time. And then for every substring, we're also going to have to check if it's a palindrome, which is linear time. So in total, we're going to have big O of n cubed time complexity. Can we improve on that? Yeah, I think so. Let's consider a smaller string here, BAB. How do we identify if this string is a palindrome or not? Well, we can look at the ends and we can check if these two guys are equal. And if they are, then we check the inner. We move this guy in, and we move this guy in, and we check if this is the same. And it is, so it's a palindrome. We can also do it this way. And maybe I'll make it two different colors, just to be clearer. We have two pointers, and they're both looking at the middle value. And they're asking, do these pointers see the same thing? Yes. They're both looking at an A. All right. So far, that's a palindrome. The blue matches what the blue is looking at matches what the purple's looking at. So we move the blue to the left, the purple to the right. And again, we ask if they're looking at the same thing. Yes, they are. Again, it's a palindrome. Which one of these should we use in our algorithm? Well, if we want, we can use either of them. This is the one that I went with. You look at B, and you ask, what is the longest palindrome with B in its center? So we initialize our pointers. They're both pointing to B. B is a palindrome. Okay, they're both pointing to the same thing. So we move the blue pointer to the left, the purple pointer to the right. Are these two values the same? Well, there's no value here. So we've gone out of bounds. So at this point, B would be our longest palindrome with B in the middle. How about A? Initialize our two pointers here. They're both looking at A, so it's automatically already a palindrome. We move the blue left and we move the purple right. We expand and we see that they're both looking at B's. Okay. That's a palindrome. We move again, decrement blue, increment purple. It's no longer a palindrome. So at this point, we just want to return BAB. All right, cool. Our final algorithm is going to look at each character in our string and then expand outwards to detect the largest palindrome with this character in its middle, which means to go through each character is linear time, and then to check to all the characters to the left and to the right is another n, which means this algorithm's total time complexity is big O n squared. Better than our last one. We've only been returning palindromes of odd length. BAB, for example, is of length 3, and A is of length 1. What if we have an even length palindrome? Then what are we going to do? Well, we can initialize a pointer in the middle, and we can initialize another pointer that is +1 of the other. We initialize the blue pointer, and then we make the purple to be +1 of the blue. If they're both looking at the same thing, BB is a palindrome. So we decrement blue, we increment purple. They're both looking at an A, so this is a palindrome. Now we're out of bounds. Our program stops at this point, and we just get ABBA returned. All right, let's look at the actual code. For both even and odd palindromes, we have to initialize 2 pointers, and the logic is exactly the same. We just decrement the blue pointer, which in this case is the I, and we increment the purple pointer, which is J, right? So it takes in an I and a J, and then it checks if those two are looking at the same value. And if J isn't out of bounds and I isn't out of bounds, I decrement I, increment K, check again. Yes, they're still equal. Decrement I, increment K. They're no longer equal. Now I return text I plus 1 to J, so returns BAB. So this function I call Palindrome Search. It just searches for the longest palindrome with I and J in the middle. Or even palindromes, set I and J like so, rooted at A. And then we would do the comparison, it would fail, we would not get any palindrome in this case. So now, for every character in the sequence, we're gonna do the palindrome search with I and J is just, they're both the same. And then we're also going to set the longest, every iteration, we're gonna set the longest to be whichever is the longer. The palindrome search, rooted at B, or the longest, which is just an empty string right now. And then we're going to do the same palindrome search for even length palindromes. All right, for every character, we look for even and odd palindromes, and we update longest with whichever is the longest, and that's it. We just return it. So let's copy that solution in, submit it. There you have it. Congratulations.